Oh, okay. Hey, folks. Welcome to another edition of the Binding Status. Um, sorry, we've had some technical difficulties getting started here, but we are ready to go now. We were streaming live, but the button wasn't pressed on the YouTube configuration. So we're good to go now. Thank you all for tuning in. And let's get right into it. So I have the roadmap pulled up here. And this Friday, we are going to be releasing version 0.7 of Crossplane. So there's a number of units of new functionality in there. We have really ramped back up after being off for the holidays. I hope that everyone who's tuned in was able to get some rest and relaxation and get rejuvenated for getting back to work. We certainly have, and in the past 2 weeks I've gotten a lot of stuff into the project, so super excited about that. We're going to be mainly talking about GKE today. So we've added new functionality in 0.6 for node pools, and also just updated GKE to be a high-fidelity representation of the Google Kubernetes API. So it'll be really nice to take a look at that, and I'll show some of the different features that are enabled by that. And then we'll also take a real close look at the Kubernetes target kind, which has newly been implemented actually just yesterday, and show the functionality it provides, the ability for provisioning onto clusters that are running existing clusters or running on-prem or anywhere that you can get access with kubeconfig. You can now provision resources from Crossplane to that, and we'll show some of that functionality, as well as consuming a single cluster from multiple namespaces. So there's a lot of different functionality that's added here, and so it'll be good to look at that. We've also begun to implement some integration testing, which this is really valuable as it actually spins up live infrastructure. So we can test to make sure that our configurations that we're using for quick starts or for our documentation and that sort of thing are working as expected on a regular basis. We can test those, on a periodic basis, rather than our tests that are run on submits of PRs and that sort of thing. So I'm really excited to see that coming in. And if you're interested in that, we have a number of issues open on the different stacks to implement that. And we already have here linked some integration tests that have already been implemented on GCP here. So this is the meta issue on the Crossplane repo, but you'll see links to others here. So if you're interested in working on that, please feel free to reach out to me directly or jump in Slack, and we can get you started on that. And besides that, we've got some work going on logging and eventing. So if anyone has used Crossplane already, if you're not new to it, then you're probably familiar of the different ways to kind of debug, and we'll show a couple of those in this episode here, which will be good. And but eventing and logging is going to make that a lot easier to consume, a lot easier to troubleshoot what's going wrong, whether it's on a Crossplane side, a user side, or on the cloud provider side. So really excited for getting some of that in, and we'll make sure to put together some demos for how to use that as well when it's enabled. So the main thing that we're going to look at today is the updates to our GKE clusters. So first of all, something that can be somewhat confusing is we currently have two versions of the GKE cluster resource in StackGCP. The reason for this is that they're essentially different units of infrastructure because of the way we previously implemented GKE clusters and then how we're going now. So you'll see that we have GKE cluster type in both the compute and container API groups. In compute, it's going to be the traditional one that if you've used Crossplane, you've utilized before. So if you look into that, you'll see fields like, let's see, num nodes and that sort of thing, which is not represented in the actual GKE API. Essentially what we're doing is bootstrapping that node pool for you. and so you didn't have to worry about that, and you could kind of get your control plane as well as your nodes in a single unit of infrastructure there. Which we do want to have that sort of functionality where it's simplified, and developers are able to request this with a Kubernetes cluster claim. But it is not currently a high-fidelity representation of the GKE API. You can, provision and spin up node pools independently of GKE clusters and attach them to them. So we want you to be able to have that functionality as well in Crossplane, and then we build, as we traditionally do, abstractions on top of that to make it simpler to consume from a developer perspective. So if we look over into the container API group, you'll see we have a v1 alpha 1 and v1 beta 1 API version. So in v1 beta 1 is going to be all of our new GKE cluster types, and you'll see things that are very detailed here, as we are now a full high fidelity representation of the GCP API. So as we scroll here, you'll see things like database encryption, enabling TPUs, cluster version, logging service, all those types of things. And we'll get into those when we actually spin up some clusters here in a moment. If you look in the v1 alpha 1 API version, this is where our node pools are. And the reason for them being at a different version is we've previously had a GKE cluster type, and we haven't previously had this node pool type. It was just kind of embedded in the GKE cluster. So when we're introducing a new API, we start with the alpha version and then progress along as per Kubernetes convention. So these node pool types are going to remain in v1 alpha 1 for the time being, and then we'll incrementally move those up. That being said, they are a high fidelity representation of the GCP API. So everything you can do on GKE, you can do with these node pool resources here, despite them being v1 alpha 1. So you can see some of the most interesting things are node pool auto scaling. You can add accelerators like GPUs, specify your image type, all those types of things. And we'll see a little bit of that here in a moment. But pretty much anything you can do on the GKE console, if you've ever used that, or via the GCP API, you can now do via Crossplane. Which was some really highly desired features for a lot of different users, because people will use a single control plane but then have certain affinity for workloads on different node pools. So enabling that has been a really valuable improvement. All right, let's look back over at the roadmap. I've explained Kubernetes target before in previous episodes. In fact, we did one where we kind of showed a whole diagram of how the system would work. So I'm not going to go into too much depth. I think it'll be more useful to see that when we actually provision resources. But essentially what it is a way to target a Kubernetes cluster. So whether it was provisioned using something like these GKE cluster types we're looking at, or it was, provisioned manually in an on-prem cluster, or on, as I said before, a Raspberry Pi or something like that. As long as you have a kube config for that, with the necessary information. So if you have like a Surface account or something like that, you can schedule workloads from Crossplane to those different clusters. So pretty much anywhere Kubernetes is running, you can now schedule from Crossplane to those clusters, which is really valuable. Another thing that, if you're familiar with Crossplane, previously you scheduled using Kubernetes cluster claims. And I'll go ahead and open up my editor here so we can kind of get a feel for what the actual YAML looks like when we're talking about this. So here's a Kubernetes cluster claim. Previously, you either selected a resource directly, as we do here, or you used label selectors to claim a resource. And when you claimed it, this namespace type, the Kubernetes cluster, would take the secret, the connection information for the GKE cluster, which is cluster scoped, but writes to a namespace. So you'll see here we're writing the connection information to Crossplane system namespace. And it would propagate that to the namespace of the Kubernetes cluster, and then you'd use something like the Kubernetes application with a selector to be able to utilize that Kubernetes cluster claim to schedule resources. So you can imagine if you can only claim a manage resource that GKE cluster once, then you can only consume that from a single namespace, because we can only propagate the secrets in that manner and schedule in that manner. The Kubernetes target is different, because you're not binding directly to a cluster type, because you wouldn't be able to, because we don't have representation of existing clusters or on-prem clusters or something like that in Crossplane at the moment, which you could build a stack to enable any of that functionality, but currently we want to go ahead and enable that. So now with the Kubernetes target, you create a target that either references a managed resource, so a cluster scope managed resource like that GKE cluster, or it references a secret directly. So if you are bringing your own cluster or something like that, you can just create a secret with your kube config in your namespace and then point a Kubernetes target to it, and then immediately you can schedule Kubernetes applications there. So I'm hoping in a future episode, maybe the next one, depending on who's available and that sort of thing, that we can go ahead and show scheduling resources onto a Raspberry Pi here in my apartment or something like that. Or just even spinning up a cluster on a cloud provider externally from Crossplane, but then scheduled to it. You'll start to see a lot of the power in that kind of system. But for today, we're just going to show some of the mechanisms that have been implemented. So you'll see here that we have this Hello World directory, and all this will be available after the show, per usual. And in it we have a GKE cluster, so this would be static provisioning where we're creating a GKE cluster directly. We have a Kubernetes cluster claim that references that GKE cluster directly. We have a node pool, so as you remember, the GKE cluster type in v1 beta 1 in the container group, which this is what this resource is, only spins up the control plane, and then the node pool is provided as an add-on, so you can have arbitrary number of node pools attached to your Kubernetes cluster. So we do need to spin that up directly, but we can utilize cross-resource references. So you'll see we can create all of these resources at the same time, and we just reference the Crossplane resource by name, and that's going to propagate all the information needed for the node pool to attach to that. And then lastly, we have this Kubernetes application, which we'll look through a little bit later. It's actually just a GCP Hello World Node.js app that we're going to deploy to a cluster. And you'll see that we're using a target selector here for labeled TBS demo, where we previously had a cluster selector. So you'll also notice that besides this Kubernetes target here, which we're not using at the moment, there is no target defined here. So if you're wondering how we're going to schedule to a target, we've built in the functionality that when you claim a resource, a Kubernetes cluster resource, and it becomes bound, then it's going to propagate the secret to that namespace as it has and automatically create a Kubernetes target. So we mentioned before that if you claimed a managed resource or dynamically provisioned it, then you could automatically schedule to that. Well, now that we're scheduling to Kubernetes targets, we didn't want to make that experience less enjoyable or easy or efficient. So we automatically create a Kubernetes target pointing at that secret that was propagated to the namespace of the Kubernetes cluster claim. So this is kind of a lot of behind the scenes that we've talked about here, but hopefully it'll become a little more clear as we actually provision these resources. So let's open up the GKE console here. So you'll see two clusters here. We're just using the TBS one today for everything we're doing. So I've already connected to that locally, and we can see what pods we have running here. So you'll see Crossplane and the Crossplane Stack Manager have been installed. This is from the master branch. It's the latest revision because Kubernetes Target will be in the release tomorrow. The previous release does not include it. Before we go any further, I want to give a shout out to the people in the chat, as we like to do. Marcus is here, probably our most faithful listener and a previous host. He says he's tuning in from New Jersey. Thanks for joining, Marcus. We have Phil, who does a lot of the roadmap shaping of what we just looked at. He's joining from Seattle, so excited to have Phil on the call. And then Jared, who is one of the founders and maintainers of Crossplane, also a faithful listener, is on the call as well. And and we appreciate the encouragement there, Jared. Let me check Slack real quickly to see if anyone has joined the TBS channel. We do have some messages here. Looks like Jared, and that appears to be it. So as I was mentioning earlier, if you have any additional topics, because we'll probably speed through this relatively quickly, please feel free to drop those in the chat. If you want us to live troubleshoot a bug or just answer any questions about how things happen behind the scenes, or even get you up to speed for contributing, please feel welcome to drop your information in the chat, ask your question. Definitely we'll get to it. I see Steven also just mentioned he does a lot of the UI stuff on Crossplane, which is cool. So he's worked on getting UI schema into the different stacks, and it looks like he's joining from Florida. So we have pretty good geographic diversity here. I'm in the middle of the country in St. Louis, and we have, let's see, New Jersey, Seattle, San Diego, Florida. So we're doing pretty good on geography there. All right, so we have the Crossplane stack installed, and I also have GCP running here, the controller. I'm running it locally. So basically I've just started the controller from my local host with credentials to connect to this GKE cluster. It would be the same as if you had installed the stack directly, but I just wanted to run it here for some local debugging. It was a little bit easier. So let's see what we have here in the directory. So we're going to look in this hello world directory. We need to make sure that I've already created this GCP provider, which is our way of talking to the cloud provider. And I believe I have already created one. Let's see. Yep. So I have created a GCP provider. This will be in the repo for you to do the same if you like. And you'll need to put in your project ID. We're using Crossplane Playground, excuse me. And then also have a secret present for it to reference, which you can see here is already existing. It's pointing to example provider GCP. So you can look through our documentation for getting your GCP credentials into the cluster. I'm not going to cover that today, but I will cover provisioning GKE clusters. So I'm just going to go ahead and bulk apply that hello world directory, and then we'll kind of go through what's happening because it will take some time to spin up. So let's see. All right, so everything was applied successfully. That's always good to see. And let's see what resources are up to here. All right, so this is a helpful state to actually see here. So we referenced this TBS demo cluster directly from the Kubernetes cluster, so it was already familiar with that on creation. If we look at it, we're going to see that it's waiting for the manage resource to become bindable. So basically for the GKE cluster to say, I'm provisioned and ready. And so if we look back up here, the GKE cluster says I'm provisioning, I'm not ready yet. So we can take a look at what's actually happening here. So this is a view of all of the resources we applied. So I'll start down here with the node pool. So as I said before, we're referencing the Crossplane resource directly. So it's going to wait for it to become ready because that's the only way it can get its connection information. And the TBS demo cluster is not available yet. So this node pool is not going to be provisioned until the cluster comes available and it can attach to it. If we go up a little higher, here's that Kubernetes cluster we were just looking at, waiting for the manage resource to become bindable. This is our Kubernetes application, which has been successfully reconciled, and we'll get into what's actually happening behind the scenes. But you'll notice earlier we saw, and if I scroll up far enough, you'll see that it's in a pending status, which means it hasn't been scheduled to a cluster yet, and we'll talk about why that's the case. And in the GKE cluster, our main resource here, we can see the different provider config, and So it did not have any references to other resources, so all of them were automatically resolved. And then we'll see that the resource is being created, so the ready condition is in false. So that's what we would expect at this point. It does take some time for GKE clusters to come up. And I'm going to pull up the console here so that you can see. So we'll see TBS demo cluster is coming up. I wonder if we caught it in time for me to show you what happens behind the scenes here. Yep, perfect. So you'll see this Crossplane bootstrap node pool. And if you've ever used Terraform or just the GCP API or anything like that, you'll probably notice some interesting behavior around how they handle provisioning GKE clusters. The issue with provisioning them via the GCP API, which is what any other infrastructure provisioning tool is going to use, and you can probably notice here that this is going to disappear in just a moment. But essentially, you can't provision a GKE cluster. You'll see that cluster size is 0 here because we just deleted that cluster implicitly. So, sorry, I keep getting sidetracked, but I wanted to show you that it's happening. But when you provision a GKE cluster, you have to attach a node pool. So it uses a default node pool. And if you want to add other node pools, that's great, but you can't create the actual control plane without any nodes. So what we do is say, we'll create it with this Crossplane bootstrap node pool, which is actually a node pool of 0. We just have to specify that a node pool exists. And then we immediately delete it. And that means that if you do not have a node pool that references this GKE cluster like we do, that you want to provision and attach as soon as it's available, then you'll get a cluster with 0 nodes, and it'll essentially say in the notifications here, pods are unschedulable because there's no nodes for them to run on. So that makes sense. And we're not really seeing that here because we are creating that node pool directly, but you can create a GKE cluster and have it with no node pools and just kind of have it sitting and running. I'm fairly certain you actually don't even get charged for having the cluster there. So, you know, that might be a useful way to have some long running clusters and just attach node pools when needed. But we have attached a node pool here, so you'll see it's provisioning. And I think it's just about ready. Yep. So important thing about node pools and about GKE clusters, you can have zonal or regional clusters. So this is a zonal cluster, which you'll see denoted with a letter at the end of the region. So that means it's just in one zone of that region. If you create a regional cluster, it'll be across the zones in that region. And an important thing to note is if you provision a node pool that references a regional GKE cluster, then you'll see if you provision something like initial node count 1 in a regional cluster in US Central 1, there's 3 zones there, so it's actually going to create a node in each of those zones. Here we're using a GKE cluster that's zonal, US Central 1A, so you'll see that our node pool actually only has 1 node in that one region. So that's just if you're not familiar with kind of multi-zone GKE clusters, that might be helpful when provisioning, or you might provision a regional one and then wonder why you're getting more nodes than you specified. Importantly, to create a regional GKE cluster, and this is the same with the API or the console, we could just simply eliminate the A there, and it would provision a regional cluster in US Central 1. But we're going to keep that for now. And let's check back in now that our node pool has been created and attached to our GKE cluster, and they appear to be running successfully. Let's check back in on our resources here. And it looks like Suraj has joined. Suraj is in our Slack channel very commonly, and he has helped a lot with the Crossplane community. I am personally really grateful for some work Suraj has done because when we were implementing these GKE node pools, he actually noticed an issue with them that was around basically connecting to them using Kubernetes applications that were scheduled to them and getting the credentials from that. And might do a future post on the blog or maybe an episode of TBS that talks about how authentication happens with GKE, which is basically a subset, or you could look at actually as a superset of the Kubernetes types of authentication if you wanted to, depending on if you're saying that using GKE service counts is outside the number of ways to authenticate to a Kubernetes cluster, or a subset of the OpenID Connect connection options. But essentially what you can do is use basic authentication, service count tokens, Google service counts, which is the recommended way of authenticating to a GKE cluster, or you can use client certificates, and there's a number of different ways to do that we'll likely cover in a future episode. So to look back here at the resources, our GKE cluster, it's running and bound, and all appears to be good here. You'll notice there's no cluster class. That's because we created this statically, right? So we didn't use a configuration from a GKE cluster class. We actually just provided it directly. Our Kubernetes application, you'll see this here in the cluster, which we'll talk about in just a second. You'll see the status submitted. It was previously pending. Actually, before it got to this submitted stage, if we were watching, then we would see that it would be in the pending stage. And sorry, I've got some notifications popping up here I need to dismiss. And let's see, our Kubernetes application, our Kubernetes cluster claim has become bound, and you'll see that it's referencing the GKE cluster. And then our node pool is running, and you'll see that that cluster name we provided, which was just a cross-resource reference to our GKE cluster, TBS demo cluster, has actually been expanded to the full path of the cluster. So it was able to wait for that GKE cluster to come available in Crossplane and then pull this path off of it, which allows the node pool to actually talk to the API for this GKE cluster and attach to it. Once again, we didn't use a class here, so that's empty, and the status is unbound, and that's why, because we don't have a claim type for node pools at this time. We haven't really found an abstraction across cloud providers, and in a little bit I'll talk about how we might go about claiming both this GKE cluster and this node pool together at the same time, because we're doing some work on that, because obviously, as I mentioned earlier, you want some abstractions where you say, I want my default GKE cluster, which comes with, 3 nodes or something like that. And I'm going to take a quick drink here. Let's see if we have any comments here in the chat. Marcus is singing the praises of a 0-node cluster, and Suraj mentions that we had a quick fix on that issue that he identified, and that was one thing I was really proud of that issue is the Crossplane community was able to work together to get a fix in place in actually I think less than 14 hours and get a patch release out. So that was really cool to see, and we try to have that kind of responsiveness when we notice there's something wrong in one of our releases. All right, so let's look into what is happening here with the Kubernetes application, which once again is how we're provisioning our actual workload onto the Kubernetes cluster that we provisioned. So this is kind of interesting here. Usually that would be a reference to a Kubernetes cluster, or in the past it would be a reference to a Kubernetes cluster. But obviously that is not the name of our Kubernetes cluster here. And we mentioned that we've moved to using Kubernetes targets. So let's see if we can find any Kubernetes targets. Well, it looks like there's one with this exact name. And if we look at the actual contents of that, you'll see it has a connection secret ref to Kate's cluster, which you'll also notice is where we mentioned we wanted to write our reference in our Kubernetes cluster claim. So I mentioned before we didn't want to degrade the experience of claiming a cluster and immediately being able to schedule to it. So what we did was automatically create a Kubernetes target when a claim becomes bound. So earlier we looked to see if a Kubernetes target exists, and we noticed that the status was not bound. But as soon as that status became bound, the full workflow of what happened is the connection information for the actual GKE cluster was written to this TBS demo secret in Crossplane system, and that happened during provisioning of the resource. When the claim became bound to it, which it did as soon as it became ready, you could also claim things at a later stage. Then that secret was propagated from Crossplane system namespace to the default namespace, and a K8s cluster secret with the same contents was created. Because we're using Kubernetes targets to schedule now, though, in that same default namespace, which we just looked at, the Kubernetes target was created and referenced the same secret that the Kubernetes cluster claim had propagated from the managed resource. And you'll also see, importantly, so that we don't have orphaned resources lying around. Let me see if I can get the terminal to come up here. That there's an owner reference actually to the Kubernetes cluster, and you'll notice the UID of the Kubernetes cluster claim is actually the name of the Kubernetes target. So having an owner reference means that when we delete the Kubernetes cluster claim in this namespace, which would lead to the GKE cluster becoming unbound, then this is also going to get cleaned up, this Kubernetes target. Because if you have an owner reference and you delete the owner, then the resource is collected by garbage collection. So that's really handy because it would kind of be a bad experience or a bad architecture for us to have a GKE cluster existing that was unbound. So when something becomes bound, it essentially means it's in use. And now we're saying that a GKE cluster can be used in multiple places. But we don't want a GKE cluster to be used while it's unbound. So even if we're using a GKE cluster in multiple namespaces using targets, then we still want it to be in the bound state for it to be in use. And that's why when we create these Kubernetes cluster claims, we have the owner reference so that they're cleaned up when it becomes unbound. Something else to mention here that we could take a quick look at, and I believe I have a resource in the repo to show this. So we have another Kubernetes target that we could create directly that references this GKE cluster we created. I'm going to show that briefly to show how you can get connection information in different namespaces. So first of all, let's look at what namespaces we have in this cluster. So we just have Crossplane system and default. Crossplane system is where the pods for our controllers are running, and also where some of our infrastructure is writing its secrets. And default is where we provision the Kubernetes cluster and the Kubernetes application. So let's also, to show that we can do this in multiple namespaces, create a namespace target demo. Oh, I actually missed that. So we already have one available. Let's make sure that in the target demo, we don't have any Kubernetes targets in existence. So we just have that one in the default namespace. So we'll go ahead and create our new Kubernetes target, which I just showed in that target demo namespace. So we'll see that's created. And if we looked over at the controllers here, you'll see that we successfully reconciled a Kubernetes target resource. The reason why this was picked up by the stack GCP controller is because we were referencing, let me get my editor up here. We are referencing a GKE cluster type directly. So GCP is essentially saying, I know about that cluster type. So it's my job to reconcile this Kubernetes target. And we want that secret written to the propagate me secret in the namespace of the Kubernetes target. So let's take a look at what secrets are present in the target demo namespace. All right, so you'll see the propagate me secret is populated. I'm not going to show the actual contents since it will have connection information for the GKE cluster, even though we're going to tear it down right after this. But let's compare that to the secret that was propagated using the Kubernetes cluster claim in default. Well, if we do get secrets, it'll default to default. And you'll see this K8s cluster has the same data as opaque, and it's going to actually, if you examine the contents, be the exact same secret. And both of these are actually coming from this connection secret in Crossplane system that the managed resource created. So you'll see the TBS demo resource, and it's going to look about the same as others. So once again, if you looked in all of these different secrets, they would have the exact same contents. So now you can use any of them to schedule. You traditionally do not use a managed resource created connection secret directly for scheduling, but if it is bound, you're now able to schedule to that if you had a Kubernetes target in the Crossplane system namespace that referenced it directly. That would be a bit of an anti-pattern, I'd say, but it would be possible. So let's get back to looking at our Kubernetes application, which is our actual workload that we're provisioning. So once again, we saw it was submitted. It's using that auto-created target. And let's look at the actual resources, which are, let's see, server doesn't have type Kubernetes application. Applications resources, there we go. Got a little worried there for a second. So these are the different things that are templated out in our Kubernetes application that we want scheduled to this cluster represented by our Kubernetes target. It looks like they're all submitted. We can actually take a look at this, and if you're watching from home, you can actually use this link that I'm about to use. So looks like our service was created to expose our application in our cluster. So if we look back here, this cluster that it's running in, so we provisioned it from the TBS cluster. That's where Crossplane is running, but it was provisioned into the TBS demo cluster, and it was using port 8080. So let's see if it's available here. Yep, hello Kubernetes. This is just a simple hello world app that GCP provides in a containerized format. And if we actually want to look deeper into this, we can see that we should have a service provisioned here. Yep, test app. It's a load balancer in the TBS demo cluster, so that's what's exposing our application. And if we look at the workloads, we'll see this hello world deployment, which if we look back over at the Kubernetes application, if I can get my computer to work here for us. If we look back over at our Kubernetes application, we can see, first of all, a namespace that we created in the cluster, the service, which exposes our application using labels. So it's using this app test app label to expose this container port. And then you'll see we have two replicas in this deployment, which is reflected by this. So two pods running this deployment in the TBS demo cluster. So this is a pretty useful mechanism to be able to provision things. Maybe before we go here, I'll show how we could attach another node pool to this GKE cluster, just to kind of demonstrate the ability of having them as a separate resource. So we'll call this node pool 2 YAML. I'm just going to copy over some of the configuration here. And maybe we'll take a look at how we can, let me save that. If we can take a look at some of the functionality that we could enable here. So we're going to call this TBS demo node pool 2, once again referencing that cluster, which will be immediately available. This should actually be write connection secret to ref, although it's really, well, actually I'll just eliminate it completely because it's not needed for node pools because we don't have connection secrets for that. So let's look at stack GCP and see if we can enable some of these cool features that are available in node pools. All right. So we could do some auto scaling configuration. That might be kind of cool. Let's do auto scaling, and we'll start out with enabled, and we'll actually just enable all of these. So let's make our initial node count 2, and then we'll say auto scaling, and in this stanza we had enabled, and we want that true. Let's see what else we needed to make sure that works. This is also available in our API documentation, which is probably an easier way to look at this, but since we have this open, okay, auto provisioned and max and min node counts. So auto provisioned equals true, max node count, we'll say 3, and min node count we'll put at 1. All right. Anything else? We'll just do that for now. I'll leave looking at any of the other features enabled on node pools to you guys at home. So let's see if we can find where I applied these for. We went -r. So I'll just apply over. None of the other resources will be changed. So it should just add this new node pool. Yep, so you'll see created. Oh, demo node pool was configured. I don't know what we changed in that, but I guess we'll see. Shouldn't be any different. All right, let's take a look at what's happening here. All right, so it looks like node pool 2, it got the cluster name correctly. Node pool 1 is still running as expected. Let's see if everything went accordingly there. Let's see. Node pool auto scaling. So min node count cannot be created or cannot be specified when auto provisioning is enabled. So let's hop back over and we can just change that spec and it should be reconciled correctly. And that's one of the helpful ways to debug anything in Crossplane. Since we do contact the API directly on your behalf using your credentials, or I guess you contact it directly as you'd be running Crossplane, then we're able to see really verbose errors across the board for anything that happens because we're actually getting it directly from the cloud provider. All right, so we'll see it's configured there, and when we get it, so auto provision is not enabled in this cluster. All right, so we're gonna just go ahead and remove auto provisioning, but if you wanted to, you obviously need it enabled on your cluster. So I'd encourage you to do that. But we will just demonstrate this functionality for now. All right. Let's see if it's working for us this time. All right, successfully reconciled. It's not ready yet. It's in provisioning state. So if we hop back over to our GKE cluster here, and let's just refresh this page. All right, and we'll see this TBS demo node pool 2 coming up. And you'll see auto scaling is on 1 to 3, and it looks like it's provisioning 2 instances for us. So that will be started with 2, just like we specified in our configuration, and then it'll have auto scaling enabled from 1 to 3. All right, well, that shows some of the power of the new GKE provisioning model. It also shows a little bit of the Kubernetes target functionality. So as I mentioned before, that's something that's going to be included in our 0.7 release this Friday, so tomorrow. So look for that coming out, and I'm sure we'll have some guides and future episodes and that sort of thing to show how to use it. If you're already using Kubernetes cluster claims, you can basically just start using them in the same manner by moving to this target selector rather than cluster selector, and you should see the same experience that you've had in previous versions of Crossplane. All right, doesn't look like we have any messages in the chat, and we're getting towards the end here. So I think that's about all we're going to have today. So I appreciate everyone tuning in. It's good to be back. Excited for all the different things that are going to happen in 2020 for Crossplane, and you can be a big part of that by asking for certain features to be enabled, giving user feedback, or contributing yourself. Our Slack channel is always wide open, and we'd be excited to have you there, excited to help you troubleshoot. Really strong community that we have here at Crossplane, and I'm excited to see some of them on the live stream here today. So please feel free to reach out to us. It looks like Suraj mentioned one thing here. So he made a really good point. If you see in the chat, Suraj just mentioned that because of cross-resource references, where we showed you can reference the cluster directly, then you can actually create node pools in Crossplane, and they won't be provisioned until a cluster with that name is also provisioned. So for instance, if I hadn't created the GKE cluster here with TBS demo cluster, then these node pools would be in a state of the references not being resolved. And that doesn't mean it's reaching out to GCP and getting errors back. It's actually just not even trying to, because it's saying, I can't even find this resource internally, so I'm not going to try and provision it because I'm using a reference, a cross-resource reference to another Crossplane resource. And so you could create these resources, they'd be stuck in references not resolved and just getting checked every so often. And then when a Kubernetes cluster did come available, then they'd automatically attach. So you can kind of just have these like nascent node pools waiting around to be provisioned and attached to a cluster whenever it comes up. So that's a really great point by Suraj there. And Marcus mentions that you could technically do this. So you could have node pools waiting around for multiple different clusters. You couldn't attach the same config to multiple clusters. Once again, you're not able to actually claim node pools at this point, even though we have a node pool class type. But in the future, and I said I was going to talk about this at the beginning, and I skipped over it, but I would encourage anyone who's interested in kind of like provisioning multiple resources together to take a look at this resource configurations design doc, which Nick who's one of the leaders and maintainers of the Crossplane project, has written up. And essentially what it does is allow you to specify new types that can be claimed through an aggregation of other resource types. So for instance, a GKE cluster with 3 different node pools or something like that. So that kind of functionality will be coming, which will enable you to dynamically provision node pools in a repeatable manner. Phil says, is there anything special I need to do to target a specific node pool when scheduling Kubernetes apps? So you could actually do that natively in Kubernetes with like node affinity policies and that sort of thing. So that's built in, which we can take advantage of already. And you might want to provision those types of things into the cluster using Crossplane, but we actually don't even have to enable that for it to be available. But yeah, certainly people do want to use different node pools, especially now that we have this functionality of enabling GPUs and TPUs and that sort of thing. There's definitely a desire to want to put some workloads on different node pools within a single cluster. All right, so I guess I said I was ending, but we went a little bit longer. But I appreciate everyone tuning in today. Looks like we're about right on time to finish up. So I hope everyone has a good rest of your week and a good weekend. And look out for some posts and tweets about our release tomorrow. Thanks.